Assalamualaikum and good morning, everyone. We're still waiting for a few more participants to join. Please allow another 5 minutes before we begin. Thank you. Okay, Assalamualaikum and good morning, everyone. Welcome to the second session of CREAM Webinar Series 2023. Thank you so much for spending your morning with us. My name is Intan Diana and I'll be the MC for today's webinar. For your information, CREAM Webinar Series 2023 is a new program organized by CREAM, and it is a part of our efforts to initiate conversations on issues, challenges, opportunities, and initiatives for the construction industry and beyond. And today's topic, we will be talking about mapping the future of landslide risk analysis in Malaysia. Just a little housekeeping before we get started. If you have any questions during the presentations, please drop your questions into the chat box and our moderator will bring them up during Q&A session at the end of the webinar. Now, without further ado, I would like to invite our moderator for today. Our moderator is Technologist Dr. Haji Muhammad Khairuddin Ghani. He is a manager in charge on construction industry consultancy at Construction Research Institute of Malaysia, CRIM. He has been working with CRIM for over 15 years since 2007. Since then, he has involved in many research and consultancy projects locally and internationally. He graduated PhD in 2019 from University Malaya, and he holds a master degree, bachelor degree, and diploma in civil engineering. His research interests focus on sustainability, resilient construction, project management, and facilities management. He has been involved from day one on the development of resilient guidelines on flood and landslides in 2017 until the guidelines on landslide was approved by Majlis Negara Kerajaan Tempatan. He has published many articles and journals related to construction. His most recent articles published in mainstream media on the need to use guidelines of landslide for development planning at risk and hilly areas in responding to Batakali tragedy. So without further ado, please welcome Dr. Harudin.
Okay, thank you, Madam Chair, Madam Diana. All right, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all of the participants for this today CREAM webinar series 2023. All right, so welcome to online session today. So with us today is around 60 plus participants from across the countries, as well as some of the students from universities join us to learn about the geotechnical and also as part of the development of resilient structure for natural disasters. So today's topic, after the first session last week on the flood resilience, so today we have two prominent speakers all together with Datuk Paduka Engineer Dr. Cik Hasandi Abdullah and also Datuk Zakaria Muhammad. So these are two prominent speakers are expert in the landslide, and those are involved directly with the development of guidelines for vulnerability index for landslide in Malaysia. So today's session is looking into the mapping the session with the team of the mapping the future of landslide risk analysis in Malaysia. So we were grateful today to learn to hear and share the experience from this expert to talk about the recent guidelines that have been approved by the Malaysian Majlis Negara Kerajaan Tempatan last June 2022. So the guidelines actually was developed way back 2017. And for your information, Datuk Paduka Engineer Dr. Cik Asandi was the chairman of the development of the guidelines. So before we start with the first session with Datuk Paduka Engineer Dr. Cik Asandi, allow me to read a little bit a brief biodata about him. So Datuk Paduka Engineer Dr. Cik Asandi was the Senior Director of the Centre of Excellence for Engineering and Technology CREATE of JKR since October 2016 until his retirement in June 2019. So before that, he was the Director of Slope Engineering Branch from 2011 to 2016. So after his retirement from JKR in June 2019, he is actively involved in the Board of Engineers Malaysia, as well as involved with the talk and seminar session organized by CREAM and CIDB. So I think Datuk Paduka Engineer Dr. Cik Asandi has a vast experience. He graduated from PhD in Geotechnical Engineering from University of Wisconsin at Madison, USA, and his master's degree on Geotechnical Engineering from University of Ehime, Japan. With more than 24 years experience, we believe that Datuk Paduka Engineer Dr. Cik Asandi have quite well versed in especially in geotechnical engineering experience. So with that, I think we invite Datuk Paduka Engineer Dr. Cik Asandi to give a presentation on the first round of presentation. I think Datuk Paduka, the floor is yours. I think you can introduce, I think around 45 minutes. Okay, Madam Chair. Okay, the presentation will be on 45 minutes of presentation. Okay, Datuk Paduka Engineer Dr. Cik Asandi.
Thank you, Dr. Khairudin. Assalamualaikum and good morning, everyone. The title of my presentation today is Mapping the Future of Landslide Risk Analysis in Malaysia. And it'll be focused on the manual and also the guidelines that has been produced by CREAM recently, which was approved last year under MNKT.
Datuk
Yep.
Paduka, we have a bit problem technical problem on the slide presentation. Maybe give him a bit time to sort it out.
Okay, but let me just before we start with the presentation, maybe for those who holds a PE registered with BEM, Board of Engineers. I'm also involved a lot in the Board of Engineering, the Board of Engineering Malaysia, ataupun Lembaga Jurutera Malaysia. For this kind of session, you can apply for CPD hours. That means in this case we start at around 9 until 11:30 or 12. Maybe you can claim about 2.5 or 3 hours. So that doesn't mean that anything which is not approved in the sense CPD approved by BM formally doesn't mean that you cannot claim for them. So, but of course, if it is approved by BM, then there shouldn't be any queries at all, because BM at the moment is doing a lot of audits on some of the claims by the registered person, especially the PE and PEPC. Those who PE is the professional engineer and PEPC is professional engineers with practicing certificate. So you can claim these points if you attend any courses. That would be under category 3. Okay, now I think they've sorted out the slides. I hope you can see the slide. That's the title given to us, the Mapping the Future of Landslide Risk Analysis in Malaysia, Part 1. Part 1 means there's another part which is going to be presented by Datuk Zakaria later on. And feel free to write your questions on the chat box, and we will try to answer as many as we can. Moving on to the next slide, please. Okay. In 2015, I was in Sendai. There was a big gathering of experts on disaster risk reduction in Sendai, which is in Japan, under the UN Charter Sendai Framework for Disaster Reduction. And previously, there was a Hugo framework, which was in Osaka, if I'm not mistaken. Hugo is a prefecture for Osaka. So they always have a lot of this major program in Japan, because Japan has everything there. They have the earthquake, they have a lot of landslides, they have a lot of flooding as well, they have the typhoon. So it's a completely disastrous sort of area. So we should be very you should be very you know, that we don't have that kind of disaster. So, but the 4 priorities mentioned in the UN Sendai framework was, and is still is, first you have to understand the disaster risks, what they are. For example, in this case is regarding landslide. And the second one is strengthening disaster risk governance to manage disaster risk. The third is investing in disaster reduction for resilience. This is, for example, if you use monitoring system, early warning, and so on. And the fourth is enhancing disaster preparedness for effective response. This is can be community-based government, and everybody should be involved in this matter. Not just the government, because the responsibility of safe slope is actually belongs to the owners, and also owners of the slope, which is the landowner of a slope, and also the community. Maybe if they see something which um, shows an indication that the slope is not stable, there's incipient failure, so you should report that to the authority. Maybe in the case of road, report to JKR, and in your area, then it should be the local authorities that should be looking into this. Next. So as mentioned by Dr. Khairuddin, we have the manual and we have the guidelines. The guidelines actually explain in simpler terms what the manual is. If you want to read what's behind how we get to the guidelines and so on, this is you have to read the manual. It's more detailed, and there's more things, the theory behind it, and so on. The guidelines is just simply summarizing what is in the manual. Next. Okay, this Jawatan Kuasa, or the committee, was set up in 2017, which consists of JKR. I was a chairman, and JMG, NATMA, Plan Malaysia, and PAJ, TNB, Academia. Of course, after we have done the manual and the guidelines, we present it to the stakeholders, the consultants, the contractors, and so on, to get their feedback on the manual. And because this manual, as I shall mention later, put a lot of emphasis on the vulnerability of an area which is prone to landslide. So most of us, I will go through the factor of safety, what they are, and so on, and that is more on hazard part side of the risk. Actually, risk, um, uh, which I will mention later on, consists of hazard and vulnerability and the element involved in the event itself. Next. So the content, I've been given about 45 minutes to get my lecture completed. So I have the objective, background, hazard and factor of safety, element at risk, vulnerability, and finally the risk and about and benefits of the manual. Next. Let me just scroll through the uh, some of the major events that happened for the past 30 years until now, and we were shocked to um, see that a big major landslide in Batang Kali recently, where 31 people died, and this is a big landslide because the amount of earth involved, the movement of the soil is about 450,000 meter cube, which is quite substantial because the most of the biggest that we have actually recorded so far is in Bukit Antarabangsa, which is about 200 over 210, if I'm not mistaken, meter cube. Next. So okay, this is like I said, 30 years ago. This shocked everyone when this happened, which is in the Island Towers in Ampang Jaya. Ampang Jaya used to be a place where there were so many landslides, and the first one cost the life of 48 people, where one of the uh, towers collapsed. And the two towers behind, as you can see in the picture, is still there. Next. And then Bukit Antarabangsa recently, well, not quite recently, in 2008, which was about 15 years ago, killed only 5 people, which involved about 14 houses. Next. And this is in Gunung Kinabalu, where fortunately well, when I say nobody dies, well, actually there's some people that died, as those students from Singapore, as the results of the rock fall that happened while they were climbing the Gunung Kinabalu. And as you know, the triggers in Malaysia usually is because of rainfall. Landslide is triggered by rainfall, but in this case, it's triggered by earthquake. So trigger is dalam bahasa Melayu is pencetus. Pencetus. That means without that pencetus, that is just like if you shoot somebody, there's something that trigger the gun and cause the bullet to move at a high speed. So this happened in 2015. As you can see, the slope now, if you go after 8 years, if you go now, it's quite green. There's some small vegetation started growing. Next. And we have the first picture of landslides actually in 1961, which was what 60 over years ago, 62 years ago. That happens in Ringlet, where 16 people perished. So and I haven't seen any pictures of landslide, even though we have records of Kampung Kuda, I think. in Perak, where there was a rock fall and many people died as well. But we don't have that picture. That was in 1917, if I'm not mistaken. So that's what landslide can do to you, and it causes if you live, for example, near a hilly a hilly terrain, then it may cause a lot of concern, especially when it starts raining and so on. And you have to be very careful. Moving on, next slide, please. So, disaster management, there are many phases that we have to go through. For example, before anything happens, there should be preparedness. Whether that happened or not, which is another matter actually. But you have to be prepared um, um, for the landslide or the disaster, and then of course after that happened, you have the response. That would be the you know the police, the bomber would come and rescue, and even and later on look for the remains of the people in the landslide. And then you should have the recovery. What should happen? The repair, and the traumatized people should be assisted, and so on. And finally, you have mitigation, and the circle goes on. So outside, as you see, there should be early warning um, um, before, if we can, and mitigation would be under prevention and so on. Right. Next, definition of risk. I think many people doesn't know the definition of risk. A risk is actually involve three elements. One is three parameters. One is hazard. The second one is the element at risk, and finally vulnerability. Hazard is the magnitude or the probability of the occurrence of specified period of time. So hazard, for example, you can control hazard by designing, by maintaining the slope in this case, so that failure doesn't happen. So if failure doesn't happen, then you have almost zero hazard, you know, because but then nothing in this world is free, right? I mean, you build something, even your car, no matter how expensive it is, you still need to maintain the car. Similarly for slope, if you start building slope, even the not so steep slope, you still have to maintain the slope. Monitor the slope, look at it, make sure that there's no cracks, there's no concentration of water in one area, and so on. And then you have the element at risk. What are they? People, the population, the properties, could be the road, the utilities, the economic activities involved, the social activities, and so on. And finally, vulnerability. So vulnerability is the potential degree of loss that can happen as a result of this landslide. So the problem with landslides, which is more complicated, I think, than flood, is that every slope has a different properties and character. So you say, oh, for example, if it rains this amount of water in this slope, it will cause failure on one slope. But on the next slope, which is almost have the same parameters, when I say parameters, I'm talking about the physical parameters, the steepness and so on, it still hasn't failed. Why? So that's the reason, because there's so many parameters or parameters that's involved, as far as slope, what do you call that? Whether the slope will be stable or not depends on many things, not just the physical, the steepness of the slope. The geology is very important. Where there's a lot of vegetation cover, when and geology, you have so many things. Maybe whether it's there's a fault in the area, whether the area is disturbed previously geologically. And one of the cases that would be interesting for those who are interested in landslide, you should go and have a look at Gunung Pas in Perak. Next. So some landslide prone areas in Malaysia, Semenanjung, you have Selangor, which is quite active, Pulau Pinang Island, and around the Banjaran Titiwangsa, from Kedah up to Rembau, and then in Kelantan, Pahang, especially in Raub, Bentong, and and in Sabah you have the Gunung Kinabalu area, and also Sarawak, maybe not so many, in Miri and Kapit. So these are some of the landslide prone areas. Next. So the parameters, as far as hazard is concerned, the parameters that may affect the slope stability is you look at the slope height. The higher the slope, the probability of failure is higher, because failure may not start from the top. It can start in the middle. It can start at near the bottom, where water is concentrated, because water will come and then concentrate at the toe of the slope. And then you have the slope angle, and we learn from our civil engineering undergraduate class that slope angle will cause, the steeper the slope, the more likely failure will occur. But that may not be necessarily so. And then you have the cross section, and the slope shape, whether it's convex, concave. When it is convex, for example, water will concentrate in that area of the slope. But in the case of convex, the water will spread away. From the slope in concern. And the geological types of the slope itself. Adverse geological features could be the fault, the cover, the ground saturation, rainfall in the area. The higher the rainfall is, usually, most probably, a lot more landslide will occur. And the core stone boulder, where in the case, core stone rockfall may occur. Next. Okay, hazard and factor of safety. So the question that we learn, well, it's not a question really. I mean, based on our design, sometimes our professor actually did not teach us the concept behind factor of safety. They say, oh, factor of safety, this, as if we understand when we join the undergraduate classes, as if we understand what factor of safety, and well, we don't most of the time, and it's a concept that you have to grasp in order for you to understand and to use the factor of safety, for example, in the standard, or in the code of practice, and so on. Let me give you an example. Normally we say, oh, higher factor of safety means lower probability of failure. Yes, if all the factors are the same, meaning we know about the soil, we understand the soil very well, and so on. But if we have no idea about the soil, maybe we don't have any data on the soil, we didn't do any soil investigation, even though you have higher factor of safety, but as far as safety and hazard is concerned, the hazard is maybe higher in the case of those areas where we don't do a proper site investigation. That's why the coffee shop site investigation is very, very, very dangerous, because you presume that the contractor carried out the soil investigation very well, but apparently it's just they sit down at the coffee shop and come up with the bollocks and so on. Next. The elements at risk include, I mentioned earlier, risk is hazard multiplied by the element multiplied by the vulnerability. So you have property, people, services, road, vehicles, environmental, social, and political. So environmental in Malaysia is not so much. People doesn't really care so much about environmental, not yet anyway. So landslide in the jungle somewhere, even though it's a big one, nobody cares. Even though it may affect the river system in the area, unless it started to disturb the people at the uh, lower end of the river. And then, so landslide may affect the economy, social, environmental, communication, and also politics. Our landslide is, that's why every politicians went to Batangkali, because there would be political mileage as far as, you know, um, as far as you should show your concern to. I'm not saying that we should not do that, but because politically is there's points to gain out of that as well. So next. So we, if you look at the title of our manual, we mentioned critical infrastructure. What are they? According to the Cybersecurity and Infrastructure Security Agency of USA, CISA, there's so many critical infrastructure. Now we talk about agriculture. When there's wars, there's people not able to do farming because of the COVID and so on. You have a problem with agriculture, and you may have a problem with water. At the moment, we may not have, except for Kota Baru and Kelantan. Um, you have not much problem with water. Well, except for a few. Once in a while, you have water disruption and so on. Healthcare and public health, emergency services, uh, defense industry. We don't have any war at the moment, alhamdulillah. So we're not concerned too much as far as defense industry base, and also banking. All this, the list, as you can see on the picture. And we choose four critical infrastructure in this case. One is utility, communication, and energy services. And the other one is transportation system, which is we look at the road system and dams and buildings. So we carry out a vulnerability analysis for this critical infrastructure. Next. Element at risk, when element is at risk, could be population, building. There are so many travel distance from the landslide. So that means how far the landslide will go. And in the case of Batangkali, the movement is more than half a kilometer, about 550 meters, starting from the toe of the slope until the end of the landslide itself, the feet of the accumulation zone. So that's a very um, far, very long travel distance that happen, which is not common in Malaysia. And that usually indicates there's a lot of water involved in the case of Batangkali, and which is not surprising because that the area has a river going through the area. So rivers, um, rivers could usually is due to a fault happening somewhere, and water flows very well along the faults. And then Dr. Zakaria may be able to explain that better than I do because he's a geologist. But basically, we have a river which has water all the time, it's not just during rainy season. Then usually you have to remember there must be something. There's a lot of water source that goes through, and this may indicate there's a fault. So fault is something that you have to be very careful. And in the case of design as well, apart from putting culverts, there's a culvert beside the landslide area, very close to the landslide area actually, and there's also a lot of water, underground water that seeps through, and that's why you see the ground is quite soggy. In the case of, I'm still talking about Batakali, that is. Yeah, so the type of landslide and the characteristic, this how steep the gradient is. If you have a steep gradient, if it's a gradient going down all the way, then of course that is an indication that will cause the landslide to move further and further away. If, for example, you have one slope and then a flat area, then usually if there's water, it's just a normal. When I say normal, there's not much water and so on. The landslide usually is not more than the height of where the landslide is started, at the crest of the landslide. Next. Next. So okay, let no, I think vulnerability again. The slide before, yes. Let me talk about vulnerability. This many people doesn't know this. This is a debris flow in Keningau, because they say this is a river. That was a small river, and a lot of houses along this. Usually, when we have a flood in Kelantan or in anywhere else, not many people died, right? The reason being, many of us know what to do. Some, the signs are there. But if you have a debris flow, which means the flood doesn't only bring water, but it brings a lot of, especially if there is a upstream area, there's a lot of timber cutting being done, and a lot of exposed ground. So what happened when it rains heavily, and all this channel water will just converge on the small river with the timber, with the soil, with the rocks, and so on, and it just not only bring water, but at the same time, it will sweep away all the houses because of the debris and so on that hits houses. In this case, 302 people died. This was the highest, I think, highest in Malaysia, the death highest in Malaysia in Keningau, 1996. Many of you may not remember it. Maybe some of you hasn't been born yet at that time. Okay, moving on. Okay, this is a map of debris flow in a vulnerable area in Japan, as they have a map of the areas where it would be extremely vulnerable, and some areas which is still vulnerable if there is any debris flow. Next. Let me recap. Hang on. I just want to see whether I missed some of the. Okay. Right. Excuse me for a while. I'm just looking at the. Can we go? Can we move up a little before? Yes. Cap it. This is an. Okay. Let me just touch on vulnerability. If you look at these two landslides, the first one at the top, you see pictures of wooden houses and so on. This is in Kapit. carpet, I think in, what year was that? If I'm not mistaken, in 2000, and I went to this, I visited this place. So, carpet in Sarawak, 4 people died and 7 injured. 9 houses was destroyed. The volume of earth, as you can see, is not very deep. It's just a shallow landslide. Volume maybe around plus minus 500 meter cube. And you look on at the bottom at Bukit Antarabangsa. I've shown this picture earlier. 5 people died and 15 injured. 14 houses destroyed. It's almost the same, size of people, same number. I mean, 4 in Kapit and 5 in Bukit Antarabangsa. But if you can see the volume, this is the volume is more than 100 meter cube, whereas in Kapit it's only a small fraction of that. But you see the death and the destruction is almost the same. Right. Okay. Let's go to the recap as now. Right. Let us recap. Okay. Risk is actually hazard and element at risk and plus the vulnerability. Can you hear anything in the background? Secretariat, is everything okay?
Okay, Datuk. Clear.
Okay.
Right, clear. Yeah.
Clear. Not the background noise and anything.
No.
No. Okay. All right.
Just like a sound of birds.
All right. Moving on. Next. Okay. Type of risk analysis. There's a. If you look at landslide analysis and other analysis, usually it's divided into 3. Qualitative risk analysis. This is more on rasa-rasa expert opinion plus a few things. Usually this is lebih kepada, okay, I look at the hazard, it is very high. I think it's very high. And then the vulnerability side is very low and so on. So based on, kadang-kadang it's not based on statistics, it's not based on, more on what, more lebih pada feeling and also some technical expert analysis that was, so you get the qualitative risk analysis. In the case of semi-quantitative risk analysis, this is kita lebih based on statistics, and we look at the theoretical side of it and the empirical side, and then we come up with the semi-quantitative risk analysis. So dia lebih dependable, but quantitative risk analysis ni is something that you can quantify. I think the only place, kalau as far as landslide is concerned, where quantitative analysis can be done is actually in Hong Kong. Kalau tempat lain macam Malaysia apa semua ni, kita paling banyak, I was trying to do when I was a pengarah of SKC, we were going for quantitative risk analysis, tapi the data that we have is so little that is almost impossible to get a quantitative risk. Maknanya if you look at the slope, for example, we cannot say whether this type of, first kita tak tahu what type of failure is going to happen. The likely sort of failure, whether it is a translational, whether it's going to be a deep-seated rotational failure, ataupun it can be, of course, debris flow, something which we can predict better. Kalau compare dengan, so and run out pun kadang-kadang kita tak tahu what is the run out, possible run out on this landslide. Right. Moving on. Next. So then we come up with you have the hazard plus the consequence ataupun vulnerability on the element at risk. Jadi daripada situ we come up with, if you very high dengan very high, then the hazard, the risk will be very high. And then kalau very low dengan very low, you have very low lah. So that means you can sleep yang green, light green and the green, that means it's not likely that there's going to be. Kalau berlaku pun, it's just going to be a very small landslide. It's not affected. For example, kalau your slope is your slope is not more than 20 feet ataupun 4 or 5 meters high, it's not likely that that landslide will occur and destroy your house unless you're living in a tent ataupun a shanty structure buat dengan zinc and so on. But houses that is made of concrete ataupun even wood pun, a small landslide may not affect the may not cause the house ataupun the structure to move. Next. Risk process management, yang ni I think you can find that in the textbook of risk. Dia ada risk analysis and then risk assessment, risk management. Of course, we want to go for risk management. Biasanya kita buat analysis ya, risk, or whether the hazard is high, vulnerability macam mana, and so on. And then we look at you assess the risk and management. Of course, you look at you control the whole thing, the mitigation side and everything else. Next. So the objective of the manual is actually to use the latest technology yang kita ada. That means kita pakai mapping, LiDAR and so on. Lebih kepada spatial rather than individual. Of course, you can do individual, but when you do the hazard map, you look at individual slope. But still, it's just based on statistics, whether this type of slope, contohnya the element that ataupun the parameters that I've given you, the angle, slope angle, the width of the slope, the geology of the slope, and so on, whether there is likely to be a landslide or not. And the idea is also to reduce the ambiguity between developer. So kita come up with the manual. Dia lebih kita put a figure ataupun a value to each vulnerability, and we can find what daripada situ we can look at the how vulnerable the area is. In the case of Batang Kali, for example, if you have just tent ataupun kemah, that doesn't give you any protection at all. Bila berlaku even a small landslide. In the case of, for example, dalam Bukit Antarabangsa, there's one case where the depth of tanah yang timpa the victim is only about 1 meter. She died. She died because she cannot move. There's not enough air, and then the bomber datang too late to rescue. So landslide is actually once you are covered in mud and so on, after half an hour, there's no way you will survive. And I'll give indication of viability of development. Development, you can reduce the risk by putting maybe a structure, a retaining wall, or do something engineering to the slope itself. To identify you also have to identify the vulnerable infrastructure. For example, if you build a very strong, I see in Europe, for example, they built structure abutting the slope. They cut the slope, it's almost vertical, and then they built and then they anchor into the rocks of the slope, and to provide engineering planning and solution to mitigate the risk. So kalau kita tengok pada vulnerability, if you is less vulnerable, that means
Datuk, sorry interrupt. It sounds that there are kids around that.
Yeah, itulah, that's why
your
I asked.
grandchildren.
Okay, give me a few seconds.
Okay, no problem. Sorry, Datuk.
Sorry guys, itulah.
Okay, Dato'. Okay, no problem. No worries.
So sorry about the this slight disturbance. Itulah ada cucu ni masalah juga. Next.
Tanda tuju ramai.
Next. Okay. Dalam manual ni, it will provide you with the risk. Biasanya bila kita talk about hazard and risk, many people, tadilah I mentioned about factor of safety and so on. People kata, okay, we design everything to that factor of safety, okay lah, tak ada masalah. But there's still risk, especially bila you just cut a slope, and all slope requires maintenance. Dia tak macam foundation. Foundation usually if you don't disturb the area surrounding it, biasanya okay, tak ada. After a few years, settlement dah habis complete and all that, the soil becomes stronger. You won't have any bearing capacity unless you start excavating on the side of the building, which that's a different matter altogether. Tapi for slope, you still, dia macam manusia, you still need maintenance. Sampailah dia one day it may collapse, you know, because there's a lot of process going on. It's exposed to the element of the nature, hujan, panas, and so on. Kalau slope tu belum, kalau rock tu belum weather lagi, you start weathering. And then water will seep through between the rock joints and so on and reduce the strength of the whole slope. And then at the same time, kita, from this manual, you can see what are the parameters. For example, you build a strong building, as I mentioned earlier, you can reduce the vulnerability of the whole area and near the slope. Local authority pun should have more confidence because they know that you are looking not just the factor of safety of the slope, but you're also looking at the what are the vulnerable. Contohnya kalau katalah building built so far away from twice the height of the slope, jarak dia, there's a buffer, so you don't have to worry too much because dia jauh daripada, like I said, Batang Kali ni is a bit strange because katanya the slope is never ending, even when at the point of where the soil stops, it's still sloping. So the slope doesn't end there. That's one of the reasons probably why the run out is so far away. And then local authority pun, again, people will start pointing fingers. Local authority, why you approve this and so on. So they would have more confidence in approving kalau they need approval. And then so we have some same parameters that everybody would be looking at rather than just kata, oh, saya rasa ni tak bagus begini. But you have the parameters. How are you going to build this building? Is it cater for undermining of the, kalau ada landslide? In the case of, for example, the Island Towers, there's undermining of the landslide yang that goes under the, that's the reason why it fails. Tapi kalau kita design for lateral load as well, maybe it'll be stronger and the risk will be less. Next. Kita dah ada banyak undang-undang regarding tanah runtuh, Waters Act, you have the National Land Code, Street Drainage and Building Act, and then amended 2019, which I think involved maintenance of the slope, Land Conservation Act, macam-macam Local Governance Act, and so on. These are the things that ada slope element involved in it. And also kalau undang-undang kecil ni, slope bylaws, uniform building bylaws. Kemudian undang-undang negeri pula ada Sabah, Selangor dan Sarawak, ada undang-undang negeri. That involve berkenaan dengan pengurusan cerun dan tanah runtuh. Next. Akta pun, guidelines pun ada, the guidelines National Slope Master Plan, guidelines for agriculture activities in steep use slope. Dan negeri pun ada, for example, Penang recently have the Penang safety guidelines for hillside development. So macam-macam lah. Even the federal government pun ada garis panduan pembangunan di kawasan tanah tinggi in 2009. So Federal Territory has come up. Federal Territory ni pelik sikit because they use factor of safety. Factor of safety ni, kalau you have higher factor of safety, maknanya you can build closer to the, which is good and bad. Good ni kalau betul-betul the factor of safety is right. For example, dalam code kata we need only 1.5 ataupun 1.3 aja untuk natural, untuk slope, cut slope. But you build it to 2, factor of safety of 2. Jadi you can build closer to the slope. But you have to check the design. Sama ada parameters yang dipakai itu betul ke tidak. Whether the parameters is the right parameters, or they just put in the apparent cohesion too tinggi, so factor of safety is going to be high and so on. So yang ini is a bit very difficult for the authority to look at. Next. So I think Dato, I've taken so much time already. Dato Zakaria will talk about our manual in great detail, because they are the tools that you can use, these tools to calculate the vulnerability. Kita ada for every but the process goes like this. We need the geospatial based landslide vulnerability. Maknanya should be a hazard map. Kita pakai hazard map produced by JKR and also by JMG, and from that we can process and get the vulnerability and also the risk maps. Next. So hazard and risk maps ni JKR dengan JMG is the two bodies that are doing this. Now it's given to JMG, Jabatan Mineral and Geoscience, to do in those areas, for example, Kundasang and Ipoh and many areas which is prone to landslide. And in fact, DBKL also has done their risk map in the DBKL. Hazard and risk map ni, like I said, yang dulu-dulu tu dia tak ada put a figure to it. So vulnerability, dia nampak banyak bangunan, dia kata, oh, this area is vulnerable. But they don't go to which extent that, for example, the run out, the further away, for example, from the slope, that means the vulnerability will be less. The area yang that has been done by JKR and also JMG are these areas. I think many more will be done later. Next. Okay. I won't touch too much on this critical infrastructure. I've already mentioned that. Hazard, I've already spoken about it just now. And then damage, again, that it would be the vulnerability of the critical infrastructure. Next. So if you look at the dalam kita punya manual tu, and that's the tools that for you to use. It's just an Excel. You just plug in the values. For example, kalau kita tengok apa ni, it is covered, for example, under susceptibility, the apa ni, environment, landslide intensity, and also the people. People ni, they look at the how concentrated the people is. Orang yang apa ni, OKU ke ataupun tua ramai in that area, in that building or bangunan. For as far as the landslide intensity is concerned, it's the volume and also the height of this landslide. And the surrounding environment is lebih kepada the what protection you have, and the engineering protection that you put in, and so on. As far as the the susceptibility of the CI itu dia jenis. Maknanya what type of building. In the case of building, what type of building do you build? In the case of road, maybe you build your road higher than the toe of the slope. So if any landslide happen, for example, that would cause less damage to the due to the landslide. Next. Okay. I think Dr. Zakaria will mention about this. I won't go through this one. Oh, next. Next. Tadi I mentioned earlier, so again, Dr. Zakaria will talk about this one lebih detail lagi. Population. Next. And then daripada situ dia value tu kita ambil and then kita get whether it is going to be vulnerable ke tidak. This is for building. Kita jalan lain, utilities lain. Utilities could be pylon and then dam lain. Dam ni we're looking at whether landslide will cause the dam to collapse ke ataupun overflowing of the water and so on. Next. So itulah that's the definition of daripada situ kita akan dapat and what daripada value ni kita akan we can see kalau low tu what does it mean, kalau high tu very high tu what does it mean, what will happen to the structure itself, for example. Next. Ini again Datuk Zakaria will daripada how we get from the vulnerability map and hazard map dan sebagainya, daripada situ we'll get the the map, vulnerability map lah. And finally daripada vulnerability and hazard map ni kita akan dapat the risk maps. Next. Okay, bukit antarabangsa kita dah buat calculation. So daripada bukit antarabangsa punya the event tu, we come up with the next one. Next. Kita dapati that the vulnerability is high because bawah tu ada bangunan and then the slope is not well protected. Sekarang ni is so well protected dengan retaining wall dan sebagainya. It's completely different. But during that time when the event occur, the the value of the risk is high. Next. Okay, these are just the figures in a little bit terang sikit lah. Next. So daripada situ, how do we build resilient environment? This is my the conclusion. First, kita kena reduce the risk by either reducing the hazard and also vulnerability. Maknanya hazard macam mana? You can build something with higher factor of safety using real parameters of the soil. Tapi this would be quite expensive. Contohnya slope. Kalau factor of safety of slope, kita katalah kita pakai 25 degrees. Tapi kita design so that it is safer, kita less steeper slope. But the volume of earthwork will be very high and kawasan yang terlibat pun is going to be very high. So maintenance is going to be very high as well. And we can also build, for example, very far away. Jauh daripada kawasan where the toe and the build-up area is quite distant. Again, that would reduce the risk, but at the same time, the cost would be so exorbitant because you have to surrender, the developers to surrender so much land, for example. So yang tu yang kita susah nak itu tu, the risk and kita nak padankan dengan ekonomi. The next one is manage disaster risk by monitoring ataupun early warning system. Again, early warning system. I excuse me. I saw recently Ampang is going to put a few early warning system. Early warning system ni nampak elok and so on, but it's very difficult to calibrate. For example, area yang biasanya kita control is only very small area. Kita put an instrument in one area. Kadang-kadang kalau pokok tumbang jatuh on the instrument tu, kita kata landslide. But cuma pokok yang tumbang yang langgar apa ni itu, and then that cause a movement. So putting early warning system ni nampak macam senang, but it's quite difficult actually. Kita ada a lot of instrument that we use, pakai apa ni GPS lah, monitoring, pakai automatic survey lah di Gunung Pas. If you are interested, go and contact Cawangan Kejutan Cerun. They can show you if you are interested. Maybe visit this area, buat buat rombongan or something. And but you have to identify areas where the risk is too high for development. Contohnya, this area is known for landslide. It's known for geological problem, geological adverse problem. So do you want to build in this area, which is going to be very costly, and also it can be very risky as well. So kita juga kena ada reporting system. You cannot simply report everything you see, report to the authority. There should be a buffer like community NGO like Slope Watch, for example, or the community collaboration that go through you report any apa ni. Mungkin kalau you tengok pokok tumbang banyak in one area, maybe you think that it could be a soil movement. It could be soil movement, tapi it could be somebody ataupun babi hutan yang datang and then sondol all this pokok and so on. And then for habit maintenance and surveillance ni we have to do this. If you live near a slope or at the top of the slope, doesn't know what's happening at the slope itself. So yang biasanya kalau di Wangsa Maju tak silap, rumah JJ Jamaluddin Jarjis itu, you see cracks happening. People at the bottom dah tak tahu what's going on. There's no movement yet, tapi di atas sudah ada crack. So kalau nak beli rumah atas bukit lah, jangan beli bawah bukit, because by the time you know that's like your house is gone and you may be gone as well. Kalau di atas tu start cracking at your kitchen, and then you nampak apa ni your structure started to give way, nampak crack here and there, and the apron is gone, then you know that the solid movement at the top. So I think that's all. So be careful.
Okay. Yeah.
Thank you very much.
Okay. Thank you very much, Datuk Paduka Engineer Dr. Cik Asandi, on your very quite extensive information regarding to the landslide information. So we have went through the information on how does the definition of risk, the understanding of vulnerability, and also some of the case study that highlighted by the Datuk Paduka, and also as well as regulation laws and regulation related to landslide and hilly areas development. So the last slide, I think I very interesting, the message that we are going to ponder about how we are going to build a resilient environment to take some into consideration before we live in the safe areas. Okay, right. Thank you, Datuk Paduka. So I hope all the participants can pay attention, because we have another very interesting next topic of regarding to the manual for landslide vulnerability index and risk classification for critical infrastructure. So the second session will be delivered by Datuk Professional Geologist Zakaria Muhammad. For your information, Professional Geologist Datuk Zakaria Muhammad actually was the consultant of development of our guidelines actually. So he was with the team from the geo mapping technology with us since 2017. So Datuk Zakaria actually little bit allow me to read about his background. He got a Bachelor of Science in Geology from UKM in 1980. That was I was birthed at that time. So, and Masters of Science in Quaternary Geology from Free University Brussels, Belgium in 1990. So Datuk Zakaria has been working with the JMG, Jabatan Mineral and Geology, Malaysia, since 1980 until his retirement in 2015. So when I saw the about the biodata, very vast experience, especially in sitting on the many professional institute related to geology. So being a geologist, that I believe Datuk have well versed in the especially in the international collaboration with ASEAN and JICA program. So Datuk also sit on the NATMA as a scientific expert panel, as well as body for the Construction Industry Development Board at that time during the Construction Industry Transformation Program. So currently, Datuk Zakaria is a chairman of Malaysian Board of Geologists, adjunct professor and a research fellow for DPPC, Disaster Preparedness and Prevention Center of MGIT UTM Kuala Lumpur. And currently, Datuk Zakaria is a chairman of the companies owned by Datuk Zakaria, Johor Mapping Technology Group, GMT, and his research areas in understanding risk, landslide hazard risk assessment, resilient critical infrastructure, and also community-based project related to disaster risk reduction. All right. So with that note, I think Datuk Zakaria, you can share your talks and presentation around 45 minutes to us so that we can know a bit more about the manual for landslide vulnerability index. Okay, Datuk, please.
Thank you very much, Technologist Dr. Muhammad Khairuddin. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Very good morning to all the participants. And thank you to Dr. Sandi, which has explained about the manual a little bit just now. But I would like all the participants bear with me for 45 minutes. Follow my presentation about the manual for landslide vulnerability index and risk classification for critical infrastructures. This is a very important manual to me because this is the first document officially, published by the CIDBs and also endorsed by the KPKT, if I was told, to be used at the local levels. As you know, as introductory, is the word vulnerability actually is quite new in the literature globally. It appeared, I think, 20 years ago, but in Malaysia is 10 years ago. But before that, we talk about susceptibility, hazard, and risk. No vulnerability words that come out at all. So there's an opportunity for the researcher to explore this. There's a lot of knowledge gap about the vulnerability itself. Can you next slide, please? So my presentation, next slide, please. Hello. Yes. I want all the participants follow me step by step so that I hope when at the end of this my presentation, we understand better about the manual for the landslide vulnerability index and risk classification, meaning that we can do a mapping or assessment of the vulnerability components and also a risk component. That's very, very, very important. So the manual is produced to explain and elaborate with the case study on the methodology of assessing and developing the parameters indicators of landslide vulnerability assessment and risk classification of critical infrastructures. So it's a very specific for landslide. And of course, if you want to do this assessment, first thing we need to know is the type of landslide itself, because each landslide give a different impact to the critical infrastructures. Next slide, please. So these are committees who prepare manuals, led by the Datuk IR Dr. Cik Asandi. And I was with the guideline committee earlier than this. So okay, next please. So I think maybe audience have read this two document, manual and also guideline, and maybe you already use it. Or if not, you just follow me and we see there are three parts. First is landslide vulnerability and risk analysis framework. And then after that, framework of landslide vulnerability assessment. Then we talk about determination of the risk index. So there's a three very important components. We begin with the hazard component, which we didn't touch here because Datuk Sandi already mentioned about the hazard component. The focus of the manual is about landslide vulnerability index assessment. And of course, at the end, come up with a risk index, a combination of hazard and vulnerability components. Okay, next. So first thing, for those who are not maybe new or maybe we need to know a different type of landslide because different type of landslide, different impact to vulnerability components. In this classification, I think a famous classification, the type of landslide we divide by the material on top, whether it's a rock or soil or earth or mixture of rock and soil. I mean debris, we call it. And mechanic of the movement on the left side, you can see a fall, a slide, and flow. Normally, when we have seen on soil flow, usually a slide type of earth movement. There are two rotational type and also translational types. You see the pictures at the middles. Another one is now recently, which is very alarming, is flows. We have debris flows, and of course a rock fall. For instance, rock fall based on studies, the run out distance is not very far, usually about three times of the height. In other words, if you map out the rock fall borders, which is fall after that break out and fly, as far as it goes is normally 3 times. I mean, those ball, tiniest ball size is about 3 times, but those the bigger like the rugby balls or maybe football size is about maybe 2 times. But you have a large and huge block, 1 time of the height of the slope. That is for the rock fall. But debris flows based on a record we have. For instance, in December's debris flow in Ululangat and also in Sungai Telemon, the source for the landslide is at the high elevation. It's about 600 meter to 1,000 meter above sea level. It's about above sea level. And those million ton out of the debris can flow as far as 20 kilometer downstream. Along the way, you have borders deposit, and of course the smallest clay and silt and sand and so on. So that's why we need to know what type of landslide we are doing. We are studying in order to assess the impact of the impact component of the risk, which is the vulnerability components. Okay, next, please. So first, we must understand, we must know the definition, like Dato' Isandi did mention. Before that, if we read literature, we must know whether that literature address susceptibility component, hazard component, or risk component. We need to know that. So the difference very simple. Is this for the landslide susceptibility is the possibility of potential landslide based only on the physical asset. That meaning that they are not considering the triggering factors. But once you add in triggering factor, then that's a landslide hazard assessment. So that's the difference. That's why the definition, landslide hazard is the likelihood of landslide in the area is a function of susceptibility and temporal frequency of landslide triggering factors. In this case, rainfall triggering factor or earthquake triggering factors. That is the difference between susceptibility and hazard map. Then come to the landslide vulnerability. Landslide vulnerability assessment is the impact of landslide toward eliminate risk. That's it different. That's why we can focus on landslide vulnerability assessment only. I mean, study the impact of the landslide to the critical infrastructure, people, house, road, or utility, water supply system, environment, even agriculture sector. You can study that. That's why in the vulnerability assessment, there are many components, social components, physical component, environmental components, and also many others components. This is a very broad subject. I think we need specialize on this. When it comes to the risk, actually, I realized that we are not measuring risk directly. Actually, we are measuring hazard component, we are measuring vulnerability component. A combination of both, then we come out the risk measurements. That's it. Okay, next, please. That is which I did mention just now. Risk the probability of losses. In order to measure probability of losses, first we measure the level of hazard, and we measure level of vulnerability, and of course we map out the element risk exposed to the hazard. Then only we come out with probability of losses. So that's the process. We have a guideline for vulnerability now, and Dr. Sandi already mentioned how to measure hazard. Of course, JMG also maybe and the JCAT, they have a method for hazard assessment. But today the focus is the vulnerability component and of course risk index components. Okay, next, please. So this is a reassessment framework overall. The red box which I blocked here, that is represent information required or the process required for vulnerability components. For A, B, and C, that part is for the hazard component assessment. And the last box at the bottom, the qualitative risk assessment, that combination of the hazard index and vulnerability index. This manual gives us a way how to prepare hazard index and vulnerability index maps so that we can come out with a risk index maps. So there's a 9 step there. Next, please. So this is simplified landslide vulnerability and risk analysis frameworks. Just like I said, you see that this flow chart simply shows us susceptibility components. We need the environmental factor and landslide inventory factor, and without taking consideration landslide triggering factors. But when we add in landslide triggering factor, then there's a hazard analysis. So meaning that hazard analysis is combination of environmental factors, landslide intensity factor, and landslide triggering factor. There's the 3. When there's another part of it, vulnerability analysis component is we need to know the element of risk and exposure of the element of risk to the hazard. And then, of course, we measure the vulnerability component itself by a few parameters, which I'm going to mention later. So in the literature, vulnerability assessment, there are three types: vulnerability curve, vulnerability metric, or indicator-based vulnerability assessment. This manual, we decide to use indicator-based vulnerability assessment because now it's getting popular. Even many publications worldwide also using this because of the limitation of data, especially on the damage assessment and so on. We have the damage information, but that is not for vulnerability assessment. For compensation, for that is a different. It's not enough. So the red box again, risk is hazard and time vulnerability, and we have value there, they come out risk. Yeah? Okay, next, please. So, consideration and landslide vulnerability assessment, semi-quantitative approach, reduce generalization in the qualitative method, is a flexible compared to the qualitative method. For this manual, the semi-quantitative method is chosen due to the lack of historical data on landslide hazard and damage and loss data applicable for vulnerability assessment. You may have a damage log for compensation, but it's not for the vulnerability assessment. So we hope when we have this guideline, so later on, we have more information that is in geospatial so that we can do hazard and vulnerability analysis. You know? The justification of this recommendation follow. First, data availabilities, and then the combination of qualitative and quantitative indicators, analysis in geography information system. Now, I think Prime Minister also mentioned now we are in the world of digitalization. So we can see that later on, I mean, element at risk have been mapped digitally, building, roads, network, all the critical infrastructure in digital form. So there's an opportunity for us to use the guideline to carry out hazard and risk using indicator-based method. Yeah? So this is, okay, next please. So just now, I didn't touch this. Dato' Sandi already mentioned our reassessment method. And so we are, in this manner, we decide to use indicator-based approach because the resulting risk is relative and doesn't provide, this is a relative risk we're talking now. Only method that allow to carry out an holistic risk assessment, including social, economic, and environmental vulnerability and capacity. So there's opportunity for us to do other many others non-physical vulnerability assessment, especially for environmental impact assessment and so on. So okay, next please. So the guideline and the menu are subjected to the following limitation. We realized that we declared this. The guideline only cover physical landslide vulnerability assessment risk classification. The landslide vulnerability assessment risk analysis, we only focus on critical infrastructure such as residential house, building, road, dams, and utilities, such as a pylon or maybe electric pole and so on. Generation of landslide vulnerability risk map require a landslide hazard map at the right scale. Because now when talking about vulnerability assessment, we focus on element risk of each individual element risk or the cluster risk. We need a right scale. We suggest the right scale is 1 to 5,000 or less is better. Meaning that we need a very good geospatial data, especially data, LiDAR data and so on, or probably IPSA and so on, in order to that, in order to map out all the element at risk. No? The phase-based evaluation for vulnerability assessment analysis will consider typical landslide and critical event. That's why now, if you want to do the analysis, then first we decide, we map out what type of landslide of that particular area, then only we use this guideline. As far I have seen, this guideline is for slight type of landslide. I mean, translational and rotational type, and also debris flows. Not other type, for instance, rockfall and so on. That we can develop later based on this guideline. Okay, next. So this slide on the right side shows recommendation for the application of this manual. You see that we suggest for residential land development for near urban area, we suggested infrastructure for assessment, new urban area, redevelopment of urban area, and subdivision of rural land. And also for residential development control in existing urban area potentially affected by the landsliding within the local government area or the citywide, or development of important infrastructure, for instance, hospitals, school, bridge on the slope area, or critical communication infrastructure, major left lines such as transport, water and gas pipeline. And also we suggest we use this guideline for development of new and redevelopment of existing highway, road and railway, for rural road, urban main road, urban subdivision road. And also we suggest, if you recall, last year or last 2 years, there are many mountainous landslide happening, followed by the debris flow. So there's a timely we look at the dam as one of the critical infrastructure need to do vulnerability assessment, risk assessment. Okay, next please. So I didn't touch about this ad, but then we suggest this money should be used as a complementary to the existing rule and guideline. This manual application is suitable for assisting in decision making and early assessment as part of the approval process. This is a recommendation by the committees. Okay, next. Next, please. This is the process, how to prepare vulnerability index map. First generation of landslide inventory map, we identified the potential landslide area, body, and as well estimated runout area. And the second generation of critical infrastructure maps. I mean, we map all the buildings, houses, road, and so on, depending on what type of infrastructure we want to do. And then third, landslide exposure, and maybe overlay the landslide map and the critical infrastructure. Then we carry out the exposure analysis. Then after that, we generate landslide vulnerability cluster values. For C is suitability critical infrastructure, E is environmental factor, I is landslide intensity, and P is people. We need to prepare those maps, and after that we come out with the critical infrastructure vulnerability index maps. In order to generate a risk map just now, we need one other map, is a landslide hazard map, which we can use it map produced by JMD or JKR or maybe by the DBK for DBK area and so on. Sorry. Okay, next please. Next please. So on the right side, I want to highlight just now is that Sandy already mentioned the values we get. What is it means? For instance, building and residential area. If you have value 0.01 to 0.9, very low, mean that slightly non-structure damage. On the right side is very high, 0.9 to 1, severely damaged structure or totally destructed evacuation necessary for it. This is very good because we already have a schema. I mean what's the meaning of very low, moderate, high, and very high. Everybody use this, then it's very much easier for us to compare or understand the report later on. What does it mean, the class of the vulnerability index? Each for building, for road, for dam, and utility. In this case, is TMB pylon. We use that case study. We can add in other as well. Okay. Okay, next, please. Hello. Yeah. Sorry, saya ingat just now Dr. Sandy already mentioned This is a very important schematic risk classification metric. Hello, yeah, yeah. Oh, sekejap, saya tengah ada meeting je. Sorry, I thought from the Urustia asked me whether my sound is not very clear, so that's why I answered that question.
So far okay, Dato'. So far okay. Quite clear, loud and clear.
Okay. This is very important simplified form of the, just like Dr. Kamaru said, Dr. Sandi said just now, that first on the right side, we need to know the hazard level, very high and very low. And on the top is consequent to property, is vulnerability component. So now we are measuring vulnerability component. We have the hazard component and vulnerability component, and then we mesh. For instance, if we have very high vulnerability and very high hazard, that means a high risk. That's it. This gives us an indicator, the combination. So in order to reduce the risk, whether we can tackle on the hazard component, reduce the level of hazard, or we can reduce level of vulnerability. So we have two options in how to reduce risk. That is a give up the table there. So next, please. This is information required in order to do landslide vulnerability assessment. First, the critical infrastructures. We need information like remote sensing data like ISA, LiDAR from drone, field inspection, classification of slope, geology, condition of the slope face, drainage system, slope distress, stabilization facility, and so on. Slope information, slope gradient, slope aspect. These are information already clearly stated in the menu. And topographic map, right scale. We prefer 1 to 10,000 or 1 to 5,000. An aero photograph for the visualization of the study area for identified landslide inventory purposes. And of course, a landslide hazard map at the right scale. Okay, next. Next, please. This example, landslide inventory map, you see that based on the interpretation from the remote sensing and field data surveys, and those is the body and the expected runout area. That is a landslide inventory map. We have two body in polygon form in geospatial. So, okay, next, please. And then, of course, critical infrastructure. You just imagine. This is for I think this case study in Kamrel very low density. If you carry out in Bukit Atar, for instance, we have done it for 20 square kilometer. We have 5,000 building, 20 kilometer long road network. Every road network, every street is mapped. No, all the facilities mapped. It's a very demanding job and need a special skill. There's a tool there. They use artificial neural network and support vector machine to produce this kind of map. So I foresee that in near future we have this map throughout the country because we are talking about digitalization. We can use that for this understanding of risk assessment using this manual. Okay, next, please. And landslide analysis overlay those element risk and the landslide body and run out. And then from that, we can, okay, next, please. And just especially later on this based on our in our what they call weightage, then the geospatial can come out with this value for each component. For C component, suitability critical infrastructure on the left side, and for the environmental components on the right side. This is mapped geospatially, no, based on this index, based on the weightage value, which already established under that manuals. Okay, next, please. Next, please. And there's another components, landslide intensity components. There's a value, you can see that high to low, and also people in the building, Also, we have that map. Okay, next, please. So the combination of 4, then we come up with landslide vulnerability in that maps from high, moderate. This shows most of them is moderate vulnerability for this particular area. And okay, and these in fact you cannot see building, road, then a pylon. We did it for this. With the combination of hazard map, then come out the risk map for this. We made it just partially. Okay. Okay, next, please. Next, please. So map scale is very, very crucial, and we suggest for detailed study 1 to 5,000. Usually 1 to 2005. We know engineering drawing 1 to 500 scale. And Jupyter usually we have 1 to 10,000 for the urban area. Okay, next one, please. So this I think summary. Vulnerability identify the element risk as well as elevation of the relation with it. So we have a lot of information from here. Then IBM method promote inventory development for the element risk. For example, database for building characteristic. That is IBM this method. So we have all those information, and we can use for other purposes, for preparedness, for response, and so on. It's not only for assessing the level of risk, and we also can use those information for the response and preparedness under DRR program. Okay, next, please. So these are values, weightage given there. We have especially weighted through FGDs, engagement with the expert. But we suggest weightage for the landslide intensity and the critical infrastructure given higher weightage compared to surrounding environment and people inside the building. Okay, next. Next, please. These are the one I think that Sandy mentioned just now. We have all the weightage for each component. The beauty of this guideline, we already have a structured topology classification for building, like width and so on. That means later on, when we collect information, we are systematically collect according to requirements. Even for the number of floor protection we need. So all these components we need to collect information. So later we're going to have this information in the GIS form if we carry out landslide vulnerability in that assessment of that particular area. You just imagine we have a geospatial, and you can do wonder with this, with many other applications for this. Okay. So the main components, sustainability component, surrounding environment, landslide intensity, and people inside the building. So we consider about the landslide intensity, for instance, accumulation height. Accumulation height here, I mean, is accumulation height of the deposit of the runout material at the element at risk. Meaning, if you're talking about element at risk A, at 200 meters from the body, and how thick the sediment, accumulation there, because that represents the force of the asymptote. Landslide volume, of course, the body itself, whether it's small landslide, medium scale landslide, or large scale landslide. So we are systematically collecting information landslide in that form now. So later we can use for many purposes, and probably we can use it for the later on for develop vulnerability curve. That's why in literature there's a cycle. We begin with what they call index based, what they call indicator based method. when we have enough information, then we can, after 20 years, we have the information, then we can construct what they call vulnerability curve, quantitative vulnerability curve. We need 20 years information. It's not 1 year, 2 years, and so on. So you can foresee next 10 years, 20 years, we can have a curve. No, then after we have systematically collect information for vulnerability assessment, not for other purposes. Okay, next, please. These are details. Each component very systematic. If you want to do, just follow that. Just weightage already given there and collect the information. And then I wish next 5 years we meet, that everybody show what they have for their test area or for their study area. They will compare how the outcome of the vulnerability index met and risk met based on this. Okay, next. I suggest those carry out using this using this method and map this any particular area, they should report to CRIM, so that we know in Malaysia we have done this for certain area, so that later on we can have a group of people look at this how the maths, how it perform after 5 years, 10 years, what happening when it's subjected to many cycle of a rainfall season and so on. Okay, next, please. I think the same. Okay, that example, you just choose, and after that come out the values, 0.19, very low, meaning that's that is very low vulnerability. Okay, next, please. Next, please. So the application we suggest when there is an history of landslide, sliding of the area. Example, contoh, Bukit Antarabangsa, there is history of landslide. Now, I think MPAG already have done using this guideline to carry out detailed vulnerability in that mapping of that particular area in 20 kilometer area of Bukit Antarabangsa. That's the first I've seen I've done after the publish of this guideline. When there is no history of landslide, but the topographic detail that the landslide may occur, when there is no history of landslide, but geological and geomorphological conditions are such that landslide is possible, when there are constructed features that, should they fail, may travel rapidly and affect other CI. Let's say if we carry out the what I call run-out analysis of modeling, then we foresee based on the modeling there's a few infrastructures on the way that we can conduct this investigation. When there are forest work and agricultural land clearance in which landslide may lead to the damage to the environment by degrading stream and other stream water bodies. It should be noted that the magnitude and speed of the landslide must more significantly contribute to the severity of the risk classes of critical infrastructure. For instance, based on literature reviews for the debris flows, the speeds range from 20 km per hour to 60 km per hour, or the debris flows. So I don't know what structure can resist those forces. Okay, next. Next, please. So these examples, we use a case study, but then this our measurement, we use those at the middle of at the foot slope of the building, at the foot slope of the body of the landslide. So what's come out? You see, for those who are not, I recap, 2008, about 5,000 people affected. Filler debris destroyed 14 houses, resulting in 5 fatality, injured 415. Landslide took place at but the size, measuring 109 meter in the width at the crest and 130 meter in length and 50 meter deep. 50 meter deep is at the body, at the middle, not at the tip. At the tip is thinner, at a few meters only. The maximum runoff distance is 210 meters. So we use this case study and test it. Okay, next, please. Next, please. These are the values. Is 0.74, meaning very high vulnerability index for this scale area. So meaning that structurally break and partly destroy, and reconstruction of the started part that is highly. That is a description of the classes. Okay, next, please. So I want to mention here, there's a special landslide study, Bukit Atramasa, Ulukulan, Selangor, approved and initiated by the Selangor State Government in 2020 and managed by Ampan Jaya Municipality, and co-steering committee comprises the various agencies, including Selangor Disaster Management Office, Department of Mineral Geoscience, and Cawangan Cerun also involved, and Project Implemented Disaster Preparedness and Prevention Center, Malaysia, Japan, International Institute of Technology, Malaysia, and Geomapping Technology is a partner to this DPPC doing this work. We carry out this landslide vulnerability index assessment using manuals, these manuals as a guide, and we map about 5,000 unit of building and classified the degree of vulnerability and risk, and 20 kilometer road networks as well. And of course, 100 over slope we classified accordingly based on vulnerability index and risk based on this guideline. So, okay, next, please. Next, please. So this is the outcome of the project, the landslide disaster risk deposit. This is a database, a very important database and catalog. We have all the very detailed database for study area, every building, every street, and we carry also social vulnerability assessment of the people there based on social aspect of the vulnerability. And we have done a multi-dimensional field data for assessing landslide hazard and risk as well of that particular, all integrated causal factor, geological, geomorphological, and hydrogeographical, and subsurface information. They call it subsurface geological modeling and geotechnical modeling also done. And landslide, local landslide vulnerability index and risk classification are improved for that particular area. So this is one of the example understanding of current and future risk in all hilly developed populated area in 18th. Hopefully, after MPAJ table to the state government very soon, then we can have a talk about this topic, a case study. Okay, next one. For closing, I want to highlight here, this is a recent event. It's very important for us to know that in terms of frequency of the event of the debris flows recently, very alarming. For instance, you just imagine, I think 18 August 2021, there's a landslide, debris flows in Gunung Jerai. The source of landslide at 300 meter to 800 meter, and the flows as far as 3 kilometer, all the kampung nearby affected, 1,000 over houses affected. And subsequently, just a few months before this part is already recovered, then in December last year, there's a major, I would say, debris flow and landslide in mountainous region, in main range, boundary state of Selangor, Kelantan, and Negeri Sembilan. And so Selangor, Pahang, and Negeri Sembilan. You remember on the Selangor side, Hulu Langat, those debris flow affected as far as this Banting area as well. And of course, Sungai Terlemun, those areas affected, not only Bentun area, and also Kara and Pekan area, about 30-40 kilometers away. This is an emerging disaster we should really focusing for those researcher here, and also in February this year, Kenya Dam, huge landslide, many landslide within small area in the mountain region, and follow with Kapun Ibu. I want to highlight this because next please. Next please. This is a mechanism of this simplified mechanism. Sorry, in Bahasa, I think we remember this. In order to what happens is first few hundred of landslide occurred at the high elevation, 300 to 1,400 meters above sea level, and in terms of quantity, about in this case 2.6 million cubic meter. Sorry, 300,000 meter cube of material. And after that, followed by the debris flows as far as 10 kilometers from the source and 5 6 kilometers from the source, scoring all the river basin. I mean the pathway of the river, and we can see that the river, I mean the channels before that at 10 meters, but after the event, as far as about 60 meters. You just imagine 60 meters of material as thick as a 3 meter thick, wiped out as long as 2-3 kilometers. How many? 2.6 juta meter cube already brought down and deposit at the debris. We call it debris flood, 3.3 meter cube, and of course, lastly, normally we call it banjir lumpur, all mud flood. That's all we remember. Actually, this is a mechanism. Is emerging has need to be looked at it. So my suggestion is next, please. And then GMGs and coupled with the group of consultant and multi-agencies here come out with a hazard map. This is a hazard map, and those hazard map, high hazard, moderate hazard, and so on. Then what we can see there, those red color 412 building, and Zoom Bahaya is a yellow color is 1,271 building, and we have 2,100. This is the kind of area there's opportunity for us to use that guideline, our guideline, to come up with the vulnerability index of that particular area. That is example. Example. This is emerging hazard. We need to do that, do the mapping and carry out the debris flow modeling and look at the affected area, and come after that we assess vulnerability index and of course risk index. So with that, I would like to say thank you to all the audience. Thank you very much. Stay with me. Thank you very much. That's all. Back to you, Doctor.
Okay, thank you, Datuk Geologist Zakaria Muhammad, on your presentation just now. So that's really we get the information, hands-on information regarding to the manual for landslide vulnerability index and also risk classification. And more interestingly, that the case study that were highlighted by the Datuk, the case study with the state government on the in the Bukit Atrabangsa there. I think very interesting what we call the findings that we can share after they get the approval from the authority later on. So okay, now we would like to open for discussion for the two panelists. So for the participant, I think we can those who have some question to be posted to the our panelists. So please put in right in the chat box, so I can read through the chat box, and so can ask the question to the panelists. All right. Anyway, while waiting the question from the participants, I have a few questions to the panelists. So maybe the first question to Datuk Paduka Engineer Dr. Cik Hasandi. All right. So okay, Datuk, are you ready to answer the question? Okay. All right. First question: is there any mitigation measure to mitigate the risk at the landslides as a complete cycle. Can you explain a little bit on the mitigation of the risk?
Okay. Mitigation actually means protection against a hazard of a particular slope or landslide. The main idea is actually to protect the infrastructure. That is, you can be talking about the road, you can be talking about sample the people, the building, or the dams, as we talk about the critical infrastructure. Of course, other things as well. You know, if you talk about the agriculture area, that could be. But so far in Malaysia, our landslide is not big enough. Maybe from we can see if you have a debris flow with the climate change and everything, where rainfall is happening in a very more severe, severe in terms of intensity and also in terms of volume, then you may expect this to the extension of the debris flow, or can be far-reaching. So mitigation can be done in many ways, not just engineering, because many of us are engineers. We talk about engineering side of mitigation, which is actually looking at strengthening the slope. But as far as development is concerned, maybe you can develop further away. Of course, the best mitigation is not to build anything near a slope at all, but that's impossible. Some people talk, some theories speak about, oh, why do you build road over this hilly area and so on? But the road is necessary in order for us to develop a certain areas, right? So we cannot say, oh, we have to stop developing. We can reduce the construction of new roads until we have enough money for maintenance and monitoring of the slope itself. Tapi the problem now is government likes to build, but maintenance tu kadang-kadang is haphazardly done. Similarly for development. So mitigation can be in terms of engineering and can also be communal in sense that the community understand the risk itself. You have to give them public education. Look at the signs of landslide. There are certain landslide, big landslide, and the other sign dulu. They start cracking, they start small movement and so on. You can see small movement happening here and there, the scars. Those places where you have a lot of scars, for example, you know that there's going to be there's a lot of landslide in the area. So, and lambat laun maybe small at the moment, but later on it becomes bigger. And especially kalau the catchment is big, like Datuk Zakaria mentioned, they will flow onto a stream, and then it becomes a debris flood, a debris flow, and so on. So those are the things in terms of mitigation, we have to be prepared. And the responsibility is not just for the government is not. Government will look at their property. Of course, kalau kawasan to kawasan government, jalan government and all that, that would be their responsibility. Tapi kalau what about those private? For example, developed areas are the private, belongs to private sector, to the individual. So they are responsible for their slope. So if anything happens, people can take action against them because they are negligence as far as law is concerned. Basically itulah. Jangan kita fikir pasal engineering saja. We have to think about the sociology, development side of it, and so on. Engineering is only 1/3 of the. Of course, when we have engineering, kita rasa lebih hati kita lebih tenang sikit lah. But there are many ways to do the mitigation.
All right. Thank you, Datuk Paduka, for your answers. Actually, the risk, how to mitigate the risk actually is important for us, not only take into consideration from the engineering perspective, but also we have to look into the socio-economic aspect point of that. All right. So the next question, I think I want to ask Datuk Zakaria. on the manual of the landslide vulnerability index. All right. So Dato, as far as concerned, the purpose of the manual and also the guidelines is actually to help the development, such development planning for the local authorities. All right. So can Dato explain a little bit what the best example, the good examples, application in terms of landslide vulnerability index and risk classification in such areas for under the PBT's jurisdiction. Right, Dato?
Thank you very much. I think I can share is a very good example just now. I mean, what MPAJ have done. We did it for the 20 square kilometer, and MPAJ have monitored 100 over slope, 100 over slope from almost 10 or 20 years. And then after that, when we come in, we use this in that. Then we classified those slope accordingly. Then now we realize this slope is high vulnerability, this one moderate, and then MPAJ can, I mean, the local authority can prioritize strategize mitigation. Maybe a few slope need to do immediate mitigation, the others are monitoring and maintenance, and so on. That is a very good example. Similarly, for this, also we carry out a social vulnerability assessment. Social vulnerability assessment means that meaning that we from that information we know this is a vulnerability people, this group, this street at the street level, jalan 1, jalan 2, jalan 3. So we know these are the people. This is very useful when we planning first. We for the preparedness, for response, and of course to reduce risk. This information is very useful and scientifically measured. And we have a target group. We can have a program with them. We can we call it community-based activity with them, so that they are very well prepared, and they are contribute to the how to reduce risk, like Dr. Sandi said just now. Yes, back to you, Doctor.
Okay, thank you, Dato Zakaria. All right, I can see here over here the one question from the participant with the name of Encik Faisal bin Nur Azman. So he asked the question: who is the responsible to compile all these maps after the risk assessment have been done? Is there real-time map that is online or referable right now? So I think question goes to Dato Zakaria. Maybe Dato Zakaria can give some enlighten.
This is a very important question about the sharing of the risk information to the target group. These have been discussed at various level. In fact, depend on the severity of the case. And now, at the national level, there's one program, it's a very important program, we call it CBD, Community-Based Disaster Risk Program, whereby the authority share information with the target group or that particular area during that time, but they are not posted in the open, but with the target group during the engagement. Educate them. You are in the vulnerable area, you are in the high risk area, and what do and don't, and how you contribute to the reduced risk. That is the usage of that information. For time being, it's not open. I mean, hazard information probably very soon can be open, but they're not risk information yet. I don't know. It depend on the policy at this time of time. But then I personally see, like in other country, if you go, especially those already have done it 20, 30 years of monitoring, all the information available, at a certain scale, regional scale maybe, and not the specific scale. For instance, that is my advice to the authority. That's it. That is our dream, or as how to reduce risk. Okay, thank you very much for the question.
Can I just add? I was involved a lot in the early stage of hazard and risk mapping.
Yeah.
We received, in fact, there was a cabinet directive that the hazard and risk mapping not to be open to the public.
At a particular time. Yeah. At a particular time. Yeah.
Yeah, that particular. Cuma sekarang ni, maybe if the government want to be more open, they can give another directive that says, oh, okay, hazard and risk map can be given to any Tom, Dick, and Harry who request for it. But the thing is, the problem is actually is this is very sensitive. For example, we did it in Ampang Jaya, Ampang, Bukit Antarabangsa, and those areas, and then they say and those individuals who live in area which is quite hazardous, maybe they don't know. But when we say that your area is hazardous and we have carried out a hazard map, can we expose? We just ask whether we can. They say, oh no, please don't do that, or else the price of my property will go down. So all this question, sama juga when we try to do the public education and awareness, we try to put the bunting or something, and in the certain taman they say don't put it in front of our taman because people think that our area is hazardous. So put it along the main road, so that you don't know exactly which area is. So those are the things which is the public says they want to be open, tapi bila government kata okay we open it, and it comes to their property, and they say, oh, please don't do that, it'll be detrimental to the cost of my property. So itulah until everyone understands, and want to be open, not just for their sake, but for the community's sake. Tapi at the moment, the local authority ada that maps, the local authority ada, JKR ada, JMG ada, but it's not open to the public. Yeah.
So that's an issue, right? So
yes,
we have,
yeah.
we need to tackle this, with a few groups amongst our landslide community, right? So okay, the next question, I think, since to Datuk Paduka Hasandi, since Datuk have a vast experience, take a long position in the slope engineering branch. So the question is, how can the early warning system can assist us in terms of slope management in reducing the landslide risk? For example, in Batang Kali, for example, maybe Datuk can share some information on early warning system on that.
Actually, system for apa ni, there's a lot of system that you can use. Contohnya di Bukit Gunung Pas, we use the automatic total station where we can kita pakai apa ni, that we put mirror, something like untuk kita survey the movement at many locations on the slope. Kalau kita tengok many of these total station sensor ni bergerak based on the survey, we will inform that there's something going on. You have to be very careful and inform JKR Perak, in any, so that kalau slope there's a big movement, then the road has to be stopped. This is not just the only method. There's always a small. Tapi the problem is you have to be careful because when you put satu, we try to use contohnya GPS, GPS punya tu location, but GPS is a bit expensive because you can put one area. Tapi bila kita bubuh satu aja, one movement may not give you the whole indication whether the whole slope is moving. Because satu, it could be just a localized failure, and you need to have a system whereby it will measure, when it's localized failure, and when it's a real mass movement. So this can be quite expensive, and all this method ni kena ada calibration lah. Maknanya kita tahu, kita will know that even the tilt meter pun, it tilts in one location, may not tilt in the other location. It's just a small movement in that area ataupun the whole area. Yang tu yang kita, which is very difficult and quite expensive to put. And then certain area kadang-kadang failure tu very localized, small area. In some area, the failure is bigger. So yang tu pun kita kena make sure you put the right instrument to measure those movement of this the soil. Dr. Zakaria, you want to add anything?
No, okay, then that is sufficient.
Yeah.
All right. Thank you, Datuk Paduka Sandi. All right. So the next question to Datuk Zakaria. All right. So very interesting, the manual that Datuk was presented just now. So actually, in terms of the application of the manual, is there any the impact, the benefit that can be used by the community in terms of social and also the economic impact point of that? So can Datuk give some a little bit on explanation how does the vulnerability index components can be useful for in reducing the risk? Okay, Datuk?
Yes, I think the most important of indicator-based vulnerability index assessment, we know which component is contribute to the high vulnerability. So if we address that component, then maybe reduce vulnerability index. That's very important. Secondly, we can communicate with the community during the CBDRM program. How we measures vulnerability index and risk index. And that is understandable, very easy to understand. If you use a model also on the very difficult. But then, of course, in order to substantiate about the impact, we need to have a modeling of the runout, for instance, debris flow runout. You can visualize. Actually, just before last MTL, I mean in November, we have a CBRN program for debris flow water in area of what they call Taman Eco Rimba. We have with the community who are exposed to the what they call kepala air. And we did a modeling of the debris flows, and after that we show those very so-called vulnerable area, and they reconcile with what their own experience, and they accept that. So meaning that we can share this information for the targeted group. I mean those affected community, not those non-affected community. That is, I think, that's why we are moving forward to the CBDRM program, one of the program, the package, how to, this under risk communication. So, but we need to have very reliable vulnerability in the assessment. These are the function of this guideline. So nobody can question. Using the guideline, these are the high and low and so on, then we can explain to the people. I think that is the way forward. Thank you. Back to you, Dr. Sandi, maybe you want to add. Yeah.
Itulah, the like I said, like Datuk Zakaria mentioned just now, the beauty is we put a figure to it, so it's easier. People like to, especially engineers, they like to look at the numbers. When they look at the numbers, they know. Contohnya, this number is high, and but the beauty of it is you can reduce it. You know, by putting something, a barrier or something, and then you can reduce the vulnerability. Kalau you letak a lot of barriers in front of your building, for example, then most likely the landslide won't reach to that area, even though it's quite near. So
Yes.
the thing is, by using by manipulating when I say manipulating, you're not jangan menipu. Manipulating maknanya by changing the numbers, by putting certain things that you may be able to, by mitigating it, you can reduce the vulnerability. Yeah, in terms of, I mentioned just now, contohnya kalau jauh sikit, ataupun jauh and so on. So ataupun you put a barrier, then that will reduce the vulnerability of the community ataupun building or ataupun road.
Right.
All right. Okay. Thank you, both panelists. All right. So I can see here some question from the participant. One question from Cik Faisal. I think this question is related to the report. I mean the report. I think the guidelines, right? if not mistaken, the guideline that was published by the MNKT, that approved by the MKT. So I think Datuk Paduka can answer this question. Who is the competent person to endorse the report? Or this can be done by any engineer with knowledge, but the report is not certified or valid for legal action. So I think it goes back to the guidelines that was approved by MKT, Datuk.
Okay, kita in fact produce a tool to calculate the vulnerability vulnerability index of the, katalah you have a structure ataupun even a road and so on. You can put the figures inside, and an engineer can do that. It's simple because contohnya you look at the distance daripada toe of the slope sampai ke your building. How far is it? And then you from there then on you can put berapa dia punya weightage tu, 0.2 ke 0.1 ke whatever it is, yang tu pun ada dalam the tools itself. You can choose. In fact, tools you tekan and it'll give you the drop box and tell you which one it is. That's one. And the other one is contohnya what type of building are you trying to build? Are you building a concrete or steel building which is very strong, ataupun just a wooden timber house which is not very strong as far as landslide is concerned? Jadi yang tu pun ada. If you have a different type of building, and also of course kalau the higher the building is, the stronger it is usually. As far as kalau ada small landslide, it doesn't affect the. Kalau contohnya kelas 1 story building and a building apartment, that will give you a different weightage. Jadi daripada situ you pass it. Kalau you nak develop the area, you pass it to the local authority. Local authority akan tengok based on, and data is the same because you dah tak boleh lari dah, because the building that you're building berapa jauh and so on is there. And daripada situ you get a vulnerability index, and you can also calculate the risk, multiply, because you have to have the hazard map campur sekali tu, you'll get the risk in the area, whether low ke, maybe the local authority kata anything which is a medium risk area boleh construct. Kalau high risk tak boleh. You have to do something about it in order to reduce the risk. Anything, Dr. Zakaria?
Yeah, I think it's a very explanation just now, because based on that explanation, we know which component contribute to the high risk. Is it as a component and vulnerability component? We can reduce any of that component. Can we reduce the to medium, for instance? For medium, you can develop, and then we can use that by understanding the component that contribute the high risk. That's very important. We already in the guideline already have each component of that. Okay, back to you.
Yeah.
All right.
Yeah.
So Datuk, okay. In fact,
maybe
yep.
Dr. Karudin, kita boleh share the tools because we're trying to expose everyone.
Sure. Yeah. I think we can share the tools that we have developed.
Kita boleh email to our participants so that they can use it and they have more confidence in it. Yeah.
Yes. So in fact, last year we have also conducted some series of the roadshows to the by regional. So we have create the awareness among the PBTs, consultant about the guidelines that we have developed. So in fact, this year around, we will try to reach as many as participants that can learn about how to use this manual and also the guidelines, as well as the calculators, right? So never mind, we can share the calculation after this, right? So the next question that from the Louvis, right, Ferrer Jeffrey. So do we have a one standard slope mapping pro forma to measure the landslide vulnerability? I think the best answer can be Datuk Zakaria. I think Datuk Zakaria can give some answers on this.
I think pro forma we already have. When you're talking about pro forma, is the first thing is on hazard assessment pro forma, which we have already established. JK already have it, and JMG also use the same soft of the pro forma. It's already there. I mean, to collect the right parameter for the measuring the hazard, And also now we can use a performer for collecting information